Hi everyone, welcome to the channel. In our previous video, we have learned how to validate your API request. Here in our screen, we have this DTO student class. Here, we have added a couple of validations and explored how they work. Here, we have this age validation. We mentioned that the age needs to be at least 17. And for the date of birth, with this past annotation, we have made sure that this date needs to be past date. Let's open our Postman to show you the demo. Here on the left side, we have this request, and on the right side, here there will be our response. If you send the request with a valid date, then we get the student data as response with status code 200. Now, let's try with wrong data. For example, let's change the date to 16. So if we send a request, here we are getting this response. It's 400 status code, which is bad request. And here in the response with the message, student must be at least 17 years old. So we have provided the age of the student, which is less than 17 years. And here we are getting this response mentioning what is the error and with the status code 400 bad request. Okay, this is how it works. Back to the validate, and here let me show you one interesting thing. Today when I'm recording this video is September 7, 2025, and if I make this date of birth to May, what will happen? Let's see. Send a request and it accepted. Technically, it is valid date as May comes before September, so our application accepts it. But is it really acceptable? Obviously not. And even if we update this date of birth to 1900, it is also accepted. And this is also impossible. A student who is 125 years old, seriously? Obviously, there can be some exceptions, but we cannot take them as example, right? So we need to add proper validation for this. And it is not possible to validate with existing predefined validation rules. And here we learn how to define our own custom validation. This custom validation is great if you have some custom business logic and you need to validate that. Let's try this. So, doing this involves 3 steps. Create custom validation, then we need to add validation rules to the student class and display the error message in the API response. Creation of this custom validation involves 2 steps. First, we need to create a custom annotation. I will define minimum age as our custom annotation. We will use this annotation in our field as we used our validation annotations like not null, not empty, size, and other annotations. Then we'll create a class that will hold the validation logic. So let's get back to our ID here. Let's stop our project. Here I am going to do some cleanup. I am going to do some organization of the code. Here in our root package, I'm going to create a new package. Let's say its name is validation, and inside this validation, at first let's move this custom validation exception to this validation package. So it's done. Now after this refactor, let's run this project and check if everything is working fine. Back to the Postman and send a request. Okay, it's working same as before. Now for the custom validation, what I am going to do here is create our custom annotation that will be applied the field or the method to validate these properties. For this, inside this validation package, let's create a new Java class, and here make sure to select this annotation, not class. Okay, and give it a name. Let's say the name is minimum age. Here let's close the sidebar. In this minimum age, this add interface is a special type of keyword in Java to define an annotation. Here we need to provide a couple of annotations. First of all, at the top of the class, we need the target annotation. Inside this target, we need to provide where this minimum age validation annotation will be applicable. Our annotation will be applicable at the field level and also at the method level. So first, let's add this for the field level. Element type dot. Here we have these couple of options. I want it to be at the field level. But beside this field level, I also want this to be available at the method level to provide multiple options. So to define multiple types, here we need to wrap it into curly brackets. So cut this and provide curly brackets. Inside the bracket, paste our element provider. Element type dot field. Then provide a comma, and then for the method, we need to choose element type dot method. If we have any other places where we want to add or want this validation to be applicable, we can add those by providing a comma and then the element type and the type where we want this to be applicable. So for this, it will be only for field and method. Next, we need retention with retention policy dot runtime. This tells Java to keep our annotation information available while the program is running. This is important because Spring Boot needs to see our annotations when the app is running to actually perform the validation. Without this, Spring Boot would not be able to find our validation rule. Now, next, we need to provide the class where these validations' actual logic will be located. For this, we need to add another annotation, that is constraint. Here, we need to provide the validated by, and this will be validated by this class, minimum age validator dot class. We will create this class in a moment. This is the class that will hold the actual validation logic. Now, inside this annotation interface, we need a couple of members. The first one is a string message. Here, let's provide a default value. So, if nothing is provided, this value will be displayed. Let's say it is student does not meet the minimum age requirement. Then, we'll need another member parameter for holding the value we provide in our annotation. This will be type integer and then value. These are the things that we need for this annotation right now. Now, let's create our minimum age validator class and its validation logic. In our validation package, create a new Java class and name it minimum age validator, the same as the name we provided in our constraint annotation. This class needs to implement ConstraintValidator, which uses generics. So we need to pass in our minimum age annotation and the actual type of data we are validating against. We also need to implement methods. Let's implement them. These two methods we need to implement: initialize and isValid. Now let's set up our code. First, we need to set a field here that is a private integer called minimum age. Then here in this initialize method, here we'll initialize this minimum age. We'll extract the value that we will provide in the annotation parameter. So the minimum age, this will be equals constraint annotation dot, here in this IntelliSense, here you can see the suggestions. We have these two options, value and message, that we have defined in our minimum age annotation class. Here we need the value from the annotation parameter. So our minimum age field will hold the value that we provide in the annotation parameter. Now let's come to this isValid method. This method will contain our validation logic. Here will be our core logic. We will calculate the period between the date of birth and today's date. For this, we need a new variable of type period. Make sure it's from java.time package. I'll calculate the period between these two dates using period.between. Let's rename this method parameter to date of birth. This is the value of the field that we will get as a request. Now here, as the first parameter, give this date of birth, and the second parameter provide the current date, that's local date dot now. Then in the return statement, let's get years from the period using period.getYears, and this needs to be greater than or equal to the minimum age. So with this return statement, what we're defining is that it will return true if the number of years between these two dates is the same or greater than the minimum age. Otherwise, it will be false. Now, let's apply this annotation in our student class. Open our student class. Here, on our date of birth field, we'll provide the minimum age annotation that we defined. Give it a value 17. I'll provide a message, student must be at least 17 years old. Now, start the project. Back to the Postman. Send the request. It's an internal server error. Let's check the problem. Here in the console, we have this constraint definition exception. The exception says that the class minimum age does not contain the parameter groups. Okay, back to our minimum age class. Here we need to add another parameter. So let's type class. This is a wildcard and call it groups. For the default value, we'll put curly brackets. This is an empty array and make it array. Let's start a project and check what's happening. Back to the Postman. Send the request. Again, internal server error. Let's check the Postman again. Same constraint definition exception. This time it says the constraint must contain a payload. So here is the minimum age class. Here we need to provide another class that extends payload. This will be an array and name payload and provide a default. Initialize it as a blank array. Now we can start the project. In Postman, send the request again. Here we get this error. Student must be at least 17 years. If we update the date of birth to May 15, 2000, which is more than 17 years ago, and send the request, and it's accepted. Perfect. So this is how we can create our custom validation. It rejects dates that are too recent but accept valid birth dates. So this is how we create our own custom validation rule. Let's check another scenario. We have provided the age as 25, but for the date of birth, let's give the year as 1900. I am recording this video in the year 2025. So someone born in the 1900 would be more than 100 years old. When we send it, it's accepted because it's more than 17 years. That's the rule we have defined. But this should not be like this. The date of birth should be at most 25 years back. As we have mentioned, our student age is 25 years old. So how can we enforce this rule? This time, we'll implement a separate validation logic for matching the age with the date of birth. The process is similar. In our validation package, we are going to create a new Java class. Its type annotation and name it age matches date of birth. For the annotations, we'll give it target with element type type. We are choosing type because we need to validate multiple fields together, not just one field, and we'll provide this annotation in the class level. And for the retention policy, we'll use retention policy dot runtime. Also, we need to provide the constraint, so we'll give it constraint annotation. Make sure it's from Jakarta validation. Then validated by The class name that will hold the validation logic is age validator dot class. Inside this annotation class, we need to provide a default message, string message, and default value is provided age does not match the date of birth. Next, we need to provide our groups and payload. Let's copy them from the other annotation we have just defined. Open the minimum age, copy them, and paste it in our new annotation class. Now, we'll create this age validator class. Let's copy this name, go inside our validation package, and create a new Java class. Name it age validator. This age validator similarly implements ConstraintValidator. This ConstraintValidator has generics, so we need to pass in our age matches date of birth, that is our annotation we have defined, and the actual type of data we are validating against. Here we need to provide the class name where these will be applied, which is student. We are giving this here because we are going to apply this annotation at the top of the student class. So it will take the related fields of the student class. Now we need to implement the methods. This time we'll implement this isValid method. Inside this method, we are going to put our validation logic. We'll calculate the age from the date of birth. To hold the value of the date of birth, create a new variable. Its type integer, calculated age. For calculating the age, we'll use period from java.time package. Then we need to call between, and we'll provide student.getDateOfBirth and the current date using localDate.now. And we need to get the number of the years between these two dates. What we are doing here is getting the difference between these two dates and get the years, get the number of years between these two dates and storing the age in our variable. Now for the return statement, we'll check if the ages match. So we'll return get the student age, student.getAge, check if it's matched with the calculated age. Otherwise, it will return false. Now, let's start the project and test it. In the Postman, with the date of birth in the year 1900 and student age to 25, send the request. It seems validation is not working. Let's check the issue. This is our student class. Here, I forgot to add the annotation that we have just defined. So here, at the top of the student class, add this annotation, age matches date of birth. Now start the project again, and in Postman, if we send a request, in the response, we have these 400 bad requests. Let's check the console. Here, we have these exception thrown due to invalid data. Here is the message. The provided age does not matches the date of birth. Perfect. It's working. But here is a small problem that we need to fix. Here, for this class level validation, this is throwing the exception in the console, not sending the proper message in the response. Let's fix this. To fix this, we need to update our custom validation exception class. In this handle validation exception method, we are handling our invalid request. Here, we need to make some modifications. Here, currently, we are looping through all the errors and getting the name of the field and error message. But now, we have a problem. We are dealing with both field level annotation and class level annotations. So, we need to handle both types. So, here, after this, I am going to add a if statement, and here I will check if the error is an instance of field error. We need to check for field error because this time we are not only dealing with field level annotation but also with class level annotations. If the error is an instance of field error, we'll get the associated field that is causing the error. Let's cut these two statements of code and paste them inside our if statement. Here we need to initialize a blank field name, and here update this field. Now if this error is an instance of field error, we will get the field name and store it in our field name variable. Otherwise we will have class level validation errors. In our case, for the age matches date of birth annotation, the field name will be error.getObjectName. With this simple fix, we are now good to go. Let's start project. In Postman, this was our request that previously resulted in a bad request. Now send this request again, and we have this response. The provided age does not match the date of birth. That's how we can write our custom validations. We can apply them at the field level, and we can also write validation rules for the whole class. That's all for this video. In our next video, we are going to tackle another common validation headache, JSON parse error. You won't want to miss it. I will show you exactly how to handle and fix these deserialization issues like a pro. See you there. Bye bye.